Hello, everyone. Huge pleasure to start this fifth day of the spring school with my third and last presentation. So tonight I will sleep for the first time this week very, very well. I will be here with Martin presenting some of the work that we've been preparing for you for EEG recordings and sports. This is a topic that has been growing in interest because of how technology, in particular hardware in EEG, has been developing in the past years. So I prepared a bit of slides and then we go to a more practical presentation looking at the data. So why would you want to mix EEG with sports, right? I mean, most of the reasons why people would want to do that is not only to measure physiological features from the body while, for example, someone is doing extreme physical activities, like you can see here, Christoph, very well prepared for winter conditions in Iceland with a Nautilus wireless device and a backpack with a laptop, recording his EEG data while in the mountains. So you may want to measure how our bodies respond to this kind of physical activities. You can also compare, for example, how our body is acting and comparing athletes to amateur people by seeing how well prepared and how our bodies just develop with the amount of training that professionals will have compared to someone that just did for the first time. We also can predict performance on athletes. This has been the main topic for EEG with sports up to now. Where you want, for example, athletes to perform well, and teams, sports teams use EEG and other kind of sensors to kind of predict how the body is feeling and then acting upon this prediction to make the performance of sports much better. You also can use to train and improve performance of athletes, for example, to increase concentration or decrease stress, and you can kind of try to modulate the brain activity, giving the athletes some tools to have feedback in real time. And also to find new biomarkers to use in clinical setups, for example, to know how our brain is acting during running a marathon, or for example, our heartbeat, how it reacts when we are swimming across a lake. So this could be some of the examples of why you would like to use biosignal acquisition with sports. So what kind of typical EEG markers people are using? We are using the typical ERPs, so you can use ERPs to check concentration levels of the subjects. You can use motor imagery. For example, there is a really nice paper showing subjects that were performing table tennis, and we could really see how the motor imagination was appearing automatically when they saw a video of the opponent serving, and you could see how the brain immediately performs the imagination and calculation where the ball will fall. So very good indicator of EEG marker. Spectral changes on the EEG. You do a lot of studies, like sleep studies, to know how they will perform on the next day, knowing that if an athlete sleeps very nicely, this will impact immensely the performance on the next day. And you can also combine, for example, EEG with respiration, galvanic skin response to measure nervousness, EMG for muscle tension and reaction, EOG to verify how concentrated and how the gaze is working, and the same thing for eye tracking, as many sports require a very good activity in terms of eye gazing and movement. But with all this, there are typical problems of the studies. As Christoph was mentioning, for example, of the presentations of the horses and the dolphins, human recording can also be very problematic. In particular, when there are movements going on, when the subject is performing a lot of a brusque movement. And these movement artifacts are extremely problematic because it can make your old recordings have really low quality, and then you will not have any results from what you are facing. So many of the applications in the past have chosen sports with low movement, like golf, chess, or they choose to simulate a physical activity, like I was mentioning before, that paper with someone doing table tennis, and they were watching a video and they were trying to imagine where the ball would fall. So that would not require the subject to actually perform the movement. Then there is also the problem of lack of concrete biomarkers and protocols to study, because this is something this kind of research is very new and has only been done in the past years because of the problems that typically occur when you are reading EEG from athletes. So as I have mentioned, the technology during decades did not really allow to do in-field applications. So we can see here a video how wireless changes the paradigm. We will see Martin a lot this time because he's developing a lot of these tools and testing it out, and also he's a very fantastic athlete, so we can use him a lot for these kinds of experiments. In his case, he's just doing a simple recording with a unicorn, even though the unicorn contains the hybrid electrodes. It was performing very well when he was looking at the screen and trying to classify with CVEPs. And you can see how good it is working in terms of selection of the items. So 1, 2, 3, around 3 seconds per item, and our BCI could acquire the data and classify it properly. So very, very interesting how wireless can change. And this is something that we will be seeing today, where you can see the video of Martin on the last spring school moving around, and we're having the Oscar being presented in real time and removing all the artifacts due to movement. So we will be doing something similar today. So I will not go into detail about this. So artifact removal tools that are now popping up can be very, very beneficial for these kinds of studies. So just to sum up pretty quick of all the things that we've done in the past on this presentation and also on g.tec. So the first example of us doing a study was back 7 years. We used someone that was standing on a static bike, so not a lot of movements, so lateral movements. We had a GUSP amp, which is not a wireless device, so it was standing in the table next to the subject. And then you would have the subject doing the typical biking, and we were sending audio triggers for Simulink to the headphones. Exactly. So this was one of the first trials, and it was pretty successful, as we could see that even though that there is a lot of movement, the audio evoked potentials could be very well noticed on the EEG. They serve as a distractor and test how good the quality of the EEG would be like. So if you tuned in 2002 on the second edition of Spring School, we did for the first time this EEG and sports lecture, and on that time we decided to go into the wireless setup. So we had Katrin doing martial arts with a colleague of ours. We were just using the g.Nautilus wireless device, which allows her to move around and perform the typical sports tasks. We were also delivering audio triggers through Simulink in the headphones with a tablet connected to the head. So you can see the setup is pretty simple. So you have a EEG device, a backpack, so running backpack, actually my own running backpack, still using it today, a tablet with a USB port connecting the g.Nautilus. So the g.Nautilus is sending wirelessly the data via Wi-Fi to the receiver. The receiver is also getting the triggers from the audio trigger box, which is connected also into the laptop, which is providing the trigger stimulation. And the subject is listening to this audio stimulation through the headphones. This is something that we will also try today. So you can see setup can be very, very easy to use and very simple to take away. I decided to put the tablet outside and attached it with cable binders because I wanted to really have access to check the EEG quality in real time. And to be able to start and stop whenever necessary. You actually don't need to do that, but I just wanted to have full control of it. And then I was sending the data via UDP at that time to be able to receive it on my controlling PC. So this is how the model was looking like. So you had the Nautilus connected. You were just sending the stimulation through the trigger box to the subject, and we were sending the data via UDP interface and then recording on the other side of the computer. This is how the demo was looking like. We were going outside, and even though that she was performing a lot of movements, we were able to get very, very clean EEG. So it was a highly successful demo from back of 2022. On the 2023, I decided to go more into the cognitive load, which we have seen a lot of it this spring school. So I decided to not do it this time. But mainly, there are a lot of studies which show how alpha activity is increased when an athlete is concentrated on performance of sports. So you can see this paper from Sharon et al. Where he found out that a relaxed and well-focused athlete would demonstrate large alpha amplitude before accomplishing of motor tasks. So we decided to give it a go last year. So we had people playing badminton. We used anyways these g.tec 8 channels with gel electrodes. We did the D2 classification. So if you saw my presentation from 2 days ago, it's a task where people would have to concentrate by clicking and detecting the D2. And this would give us enough information to calculate the concentration levels of the subject, which then we will be using for detecting also concentration levels during the activity of sports. So we would be looking mainly at alpha modulated behavior, as this alpha modulation is necessary for attention and working memory tasks. So we got the data, we filtered the data so that we can find the increase on alpha and theta range. We compared the active state versus resting state using this classifier that I mentioned before, and we decided to give the feedback in real time. So this is the D2 task here. The D2 task was performed before, obviously not during the sports activity, and we were getting the data in real time into our platform. So the people were playing badminton, and on the right side, we were able, during the spring school in 2023, we were able to detect how good the concentration levels of Michi were during sports by giving us on the spring school the feedback as the bar grows, indicating more concentration or decrease as less concentration. And you could really see it in real time. A shame that I didn't record the video, because every time that you had a permanent back and forth play of badminton, you were able to see the increase of concentration. And once the ball just fell down, then there was an immediate decrease on the feedback bar. Okay, so what did we decide to do this year? So me and Martin were working on a platform where we would be using our unicorn. So the unicorn has hybrid electrodes, meaning you can record with dry electrode system or apply a bit of gel to increase signal activity. And we were testing to see if someone, while doing sports, we were able to transmit all the data in real time to a second PC. So you will have the subject being able to transport a small tablet on the back, like you have seen Catherine doing, which would give complete free access to all the kinds of movements during sports. So the small PC has a very simple model, which I will be showing soon. Just collecting the data, performing the trigger. Also, that means performing the audio evoked potentials, which we will be showing soon. And the subject can then listen to the beeps either through headphones or through a loudspeaker, and just streaming the data via LSL. Okay. And then on the other side, we would have a PC, which is more robust, receiving all this data, receiving the data of the EEG plus the trigger information. And there you could have cameras, you can have screen share, you can do whatever you want with that PC, because that one is processing the data in real time. This is what we're planning to do today. So this is some of the recordings from yesterday, where we had the transmission being live from one PC to the next one. And you can clearly see that even though there is movement, you can see a very nice P300 peak on across most of the electrodes. And this time we were even using dry electrodes, which was pretty surprising. I'm really happy with it. So we are going to do some exercises today. So this will be our setup for today. It gives you an example that, for example, if you want to do some exercises like weightlifting, calisthenics, whatever, you can, for example, connect the audio evoked potentials into a loudspeaker, and you will be able to have the opportunity to have a athlete or someone that you're doing the test completely free of any cables, and be able to perform tasks, and at the same time you can verify the quality of the EEG signal. Okay, so we can soon start the real-time demo. I will just share we can just share the models that we will be using today, so that you can see. You can start. I will just shortly show the two models that we're using and explain a bit. So we will be recording the unicorn. We have the paradigm, which will then do the auditory evoked potentials, and we will send the data via LSL. So we have PC1 with this model running, collecting the data from the unicorn and transmitting it live through LSL. And then we will have the second model, which is receiving the data and the trigger as well. So you can see 4 channels EEG. 9th channel is with triggered data. We are just filtering the data with the typical notch filters and the 0.5 to 30 Hertz band pass filter. We are then calculating the triggers and doing some artifact correction with our toolbox. And then you will be able to see the EEG data and also a vector scope showing our evoked potentials. And we will have a counter showing the number of triggers that we will show. So we will also show how the Oscar toolbox is functioning in real time. I will stop sharing the screen. I will change the webcam. Hopefully you can see. You could already have seen, so you can see Martin is preparing himself. Say hello, Martin. So I will also move behind the camera so that I can control it good. Would you like to also share the screen? And I will be the host, the guy that talks and controls the webcam, cameraman. Still all good? So we will start with the raw data then. Not sure if you can listen to Martin, but I can be the translator. Just adjusting the camera for you. Alrighty, so we can already see the model running. So we will just see some raw data in the beginning, and we will see how it looks like when we are performing the task. People are always looking forward to see Martin performing stuff. So the Simulink block already started, so we can see this, I believe, left side is raw unfiltered data, right, Martin? Yeah, and on the right side is already artifact removal task. So you can see bytes on the left side, no bytes on the right side. Very, very good. So you can see this toolbox is really nice, as it's completely embedded into our hardware, and we are able to, in real time, remove most of the artifacts without really destroying essential EEG, which is something that is very complicated and most artifact removal toolboxes are unable to use. So, yeah, let's start with showing some exercises. As you can see, left side is looking worse because it's moving around. People are requesting for a backflip. He's not feeling that good today, but he will try to do it. So you can see some squats have really nice results. People are very persistent with the backflip. So yeah, like he's doing some high knees. And you see on the left side, the EEG is completely gone. On the right side, very clean data. Very, very nice results from the complete system, where Martin will now try to do heads and, okay, he's doing some push-ups really nicely. And the EEG is looking very clean, even on the hard core data. The data is already very, very good. But of course, the filtered data looks much more neatly. A headstand now. So you can see the data on the left side, the raw data and the clean data looking much nicer. And you can still see typical traces of EEG on the right side too. So very, very neat. So Martin is going to relax, close his eyes, and we can see a alpha boost on both the unfiltered data and the Oscar data. Very, very neat. And now we're ready for the backflip. Everyone just prepare yourselves. We will have some epic things happening. So we wait until the signal is stabilized, and then we will have a look at the backflip. Nice. So left side con, the backflip worked perfectly. And you can see filtered data. Perfect. Martin is happy. We are happy. So yeah, great. A great demonstration. Yeah. So we can have a look at the model. So Martin will, again, you can share the screen, Martin, maybe? It stopped sharing on my, yeah. Okay, it's back, yeah. Okay, so there was just a issue with the screen sharing. So we can have a look at the, let me switch again the camera, otherwise you just see my bald head, which is good for the pangolin, but not for the presentation. There we go. So we are now going to perform the ERP, right, Martin? Yeah. So Martin is setting up himself to do the audio evoked potentials, and we will have a look at how the data is looking like in real time and finding the difference between the unfiltered data and the filtered data, or the artifact removal data and the non-artifact removed data, and compare it in terms of evoked potentials, if we can see the evoked potentials in real time. Yesterday worked great, so I'm really hoping that today will also work good. So Martin will anyways do the movements, and we will be seeing if we can detect very nice evoked potentials. So you can see the EP scope already activated. We are expecting to have the streamline. So as I mentioned before, we have two different models, one model streaming the data and the second model just getting the data and doing all the processing. You can do this in the same PC by opening two different instances on MATLAB, or you can do it in two different PCs. The shared screen is gone again, Martin. So he's trying to share again. Sorry about the Zoom issues. And as I was mentioning, you can have the decision to have, for example, in such a setup like today, you don't really need an extra laptop or an extra machine that is going with the subject, because you can just simply put the laptop in a table next to the subject. But for example, if you want to go outside, if you want to have someone having total freedom of movement, it's much better to have, for example, a computer or a laptop and have it running while sitting on the back of the subject. That will mostly remove most artifacts. For example, for auditory evoked potentials, the best case scenario is to have the auditory stimulation coming directly onto the ear. So that could be beneficial that you have the headphones, but like I mentioned before, you can just also use some loudspeakers, very, very loud, so that you can get a very nice evoked potential. This would be one of the possibilities. You can also apply visual or stimulation, a visual or tactile stimulation. Obviously, the applications will be much more complicated because sports usually require vision and concentration. And if you're just flashing people, that will be more complicated to get some nice results. But in principle, if you think that that fits to the purpose of your studies, go ahead and try it out. Okay. Now the problem of the sharing the screen is solved. So we can already see the peaks popping up. So we have two lines. One line in orange is the one with the raw data, and the one in blue is the one where we are using Oscar and removing all the artifacts. So you can see that the data is starting to go apart as much as he moves around. I will share now again the second video so that you can have a look. So Martin will soon start to, the model stopped because of the time. So once Martin will start moving, we will be able to detect much better the difference between the data acquired during the movement versus the raw data. So model usually takes 1 to 2 seconds to start because, as you know, the typical EEG does an initial drift because of the filters. So we need to have some resting EEG, stable EEG from the first couple of seconds, and then afterwards, when it activates, you'll be able to have a better selection of the data. So as you have seen in the past, the Oscar activity was kind of okay. This is crashing a bit because of all the Zoom and everything connected. Typical problems when you're running MATLAB and into two instances or 2 times, one MATLAB and Zoom at the same time. But that's how it is. He will try again later. But as I was mentioning, you could already see on the graphic that we were showing before, where the orange activity was not showing any evoked potentials, and the blue line was showing some nice evoked potentials. This is something you can see live and compare. And this is what we're trying to show here with the models that we're running. Yeah, so this is very interesting kind of application. I think in the future we will have a lot of opportunities to try it out with different kinds of applications. Hopefully the weather will be much nicer in the following presentation, so hopefully we'll have a lot of spring schools to show you our results. We will be trying to give you some really nice presentation. Always follow our LinkedIn page, where we will have all our studies and small projects that are happening in our company presented to the users. And like that, we can give you extra updates on how the development of hardware and EEG in terms of a lot of movement artifacts and sports is occurring. Martin, are we? MATLAB is still struggling. Okay, now it's very good. Thank you so much, Martin. It was great to see you backflip. Oh, now it's starting to work. So let's see, we're almost in time. If we can fix in the next 2 seconds, and yeah, we can run in soon. Otherwise, keep writing the questions. It will be a huge pleasure to answer all of you. So as you could see, we got a live demonstration of a backflip. So you are one of the thousands of lucky ones who were able to see this in real time again. This has been a very nice opportunity to show you the potential of wireless EEG and how our artifact removal toolbox can be super beneficial for your studies. Yes, we are going back on track. We will not have too much time more as we are approaching the end, but we'll give you a last try. You can share the screen when you're ready. And we will have a look at the main differences of the filtered data. It's hanging again. So much power for one PC. I can understand that. Yesterday I also had the same issue. But as I mentioned, I can just share shortly the results of yesterday. Let me just share the screen. So you could see very nicely the results that we had, where you can see a very nice evoked potential for auditory, while there was the movement performance. And yeah, it was fantastic opportunity to show you how Oscar is working in real time. So you saw that it's working. And yeah, that would be all for me. I guess we will have a lot of questions to answer, Christoph.
EHUB is asking, when the user runs on the treadmill, this records the behavior of the brain, and we can reproduce an orthotic lag, for example, for a second person based on signals taken from several running brains. So that's a hyperscanning for prosthetic devices. Frankie, what's your opinion?
Yeah, definitely. We could. It would be a very nice project to do. Hyperscanning can have very good opportunities on detecting how different subjects not only behave in terms of brain activity, but also to give opportunity to have a much better classification methods and be able to detect everything at the same time. So very nice application. Yeah.
Then Alisa is saying she is pretty busy with the university as usual, and therefore it's difficult to see the live stream. Just visit YouTube and watch the videos again, and then you qualify also for the certificate. Chap Carp is asking, have you considered doing EEG recording on professional gamers, esports, maybe comparing to real athletes or or gamers?
That'd be a very nice project. So we can ask Michele to try it out, as he's been going a lot to conferences of sorry, gaming conferences, and that would be also a very good way to really find some nice biomarkers, and find out what differs athlete of movement sports and athlete that is doing games and esports. Yeah.
But it's of course done. People are looking, for example, at EEG traces when professional Rubik cubes players solve the cube. So it's fascinating what they figure out. Then we have Couton. What kind of technique the artifact removal method use it? It's really impressive. Maybe I can answer it. It's adaptive filtering combined with a very steep oversampling and very high oversampling and very steep anti-aliasing filtering. Then somebody from Japan, I guess, is asking the auditory visual P300 must be evaluated in different registration sessions.
Yeah, I mean, if you want to do both at the same time, it might be very tricky, I suppose, because you will have low latency, and you may have peaks coming right after the other, which would ruin the averaging that you're doing on the previous peaks. You can have it in the same session, but I suppose that you will have no benefits by having both stimulations occurring at the same time for the same subject.
And Christian is asking, have you tried to do the experiments on amateurs and professional athletes to compare it?
Us not, but there are several papers online who have done this, and you can see a very clear difference. My personal experience, what I have seen a lot is on the motor imagery, for example, where professional athletes have been having a lot of much higher accuracy rates on motor imagery compared to non-professional athletes. So by doing professional sports and by doing sports regularly, you are at the same time predicting movements and imagining the distance between yourself and what you want to do. And that increases brain activity on the motor cortex, and you will see much better results on the accuracy rate of it, for sure. You're muted, Christoph.
Some people asked about the painting behind us. So this was done by Dragan Ilic. It's an artist from Serbia, and he has also an office in New York City. And here you can actually see what he did. So he mounted many colors on a KUKA robot. That's an industrial robot that can lift 1,500 kilograms. Then he connected the brain-computer interface with the robot. And with the BCI system, you could make the decisions where the robot should actually make certain paintings and move in certain trajectories. So I played a video. So you can see one paper was placed on the vertical wall and one was on the floor. So the visitor, in this case of the Ars Electronica Festival, could select where he wants to paint and what he or she wants to paint. Then the robot was moving there and doing the painting according to the BCI controls. The most dangerous thing was actually to control the pressure, because the robot can do 1,500 kilograms. Here you can see Stella, my daughter, controlling the BCI system. On the right-hand side in blue, this is Dragan Ilic. You can see Stella is very concentrated and doing well with the BCI control. Dragan, on the other hand side, was not very good because he was always talking. And then during the Ars Electronica Festival on 5 days, people could merge in. They got connected to the brain-computer interface, and everybody painted a little bit, and the painting actually came out after 5 days of painting with different brains connected. And the painting behind us is done in a very similar way. In this case, Dragan himself was fixed on the robot. So here was his human body, and he had the pens in his hands, and then the robot was moved around with the BCI control, and Dragan painted actually the painting behind me. And after the Ars Electronica festival, I met Dragan, and I asked him if we make a deal. So I offered him a brain-computer interface for the painting, and he agreed. So I got the painting, and he got the brain-computer interface. And then I realized how big it is. So we had to construct a really big frame. And now in the seminar room, we placed the painting. And now I have the obligation to take care of the painting. So before they wanted to sell it for £25,000 in London. But now I have the expensive painting here. And Dragan also wants or has to show his painting, in different nations at exhibitions. So if he wants to borrow the painting, I also have to send it to him. And I have to protect him because he would be really upset if we destroy it or if somebody steals it, whatever. This is the story about the painting. Frankie, back to you.
Yeah, I think that would be it. I see no other questions. If you have any other questions, just let me know on the chat and I'll be answering them to you. It was a huge pleasure to present you my work here with sports and EEG. And thank you again to Martin to have everything running and doing a fantastic backflip.